in order to get this figured out.
You think you could logically figure it out by taking both the slopes and the intercepts?
Yeah. It is possible to not get an intersection, you guys. Some of these won't have an answer.
Or like if two parallel lines.
Yeah, if the lines are parallel, they'll never intersect, right? Okay. It's possible that the two lines would be exactly on top of each other.
They intersect everywhere.
They intersect everywhere.
Well,
Okay?
on that
Then
line.
any number is a solution for those. Actually, any number. There would be so many points on that line, there's too many solutions to even mention.
Well, yeah, but it wouldn't be everything.
Yes, it would be.
Well, because what about the stuff below it and above it? Those
But
points wouldn't be.
I am only interested, these are systems, I'm interested in where they're the same. And if one line was on top of another line, if you thought about that, if I had another line that was right on top of this line, this point right here is a solution to the purple line and the blue line. This point is a solution to the purple line and the blue line. This point is a solution to the purple line and the blue line. I can name so many points on here, I could never stop, could I? So every single number, ordered pair, it would have an infinitely many number of solutions. Yes, you're right that one is not a solution, right? But it has an infinite number of solutions. Okay? When you have one solution, your answer is said to be consistent. Okay? It works for one, it works for the other, it's consistent. Okay? It's also said to be independent. These kind of work together, these right here. You have to decide if it's consistent, that means there's an answer. Okay? Is it one solution or many solutions? If it's one solution, it's independent. Independent starts with an I looks like a 1. If there's one solution, it's independent and consistent. If there's more than one solution, if the lines are right on top of each other, then it would be consistent but dependent. If there's not a solution, they're inconsistent.
How is there not a solution?
If the lines are parallel, there would be
So
no
what's
solution.
consistent mean?
There's an answer.
Oh.
At least one answer. Okay? Consistent means there's an answer. Inconsistent means there is not an answer.
On a coordinate plane, as long as the lines are not parallel, wouldn't any line cross?
Yep, that's right. But they could be the same line too.
Yeah.
Okay? Alright? So this is some vocabulary that we're going to have to worry about. Consistent and inconsistent and dependent. Okay, so the only thing they want us to do on the bottom of this page is to say whether this solution is consistent or inconsistent. Is this consistent or inconsistent?
Consistent.
It's consistent. Is it dependent or independent? Independent. Right. It says, there's two lines here, by the way. There's this one and this one. So is this consistent or inconsistent?
Consistent.
Consistent. Is it independent or dependent?
Dependent.
It's dependent.
I have a question.
Yes.
On that one, if you like you could rearrange both those
Mhm.
equations to make them look the same, right?
Yep, exactly. It'd be exactly the same line. That's right. Okay. So I'm just going to show you the top of the next page because it kind of lays out what those look like for you. If it's consistent and independent, you'll have one answer and it's right there. Or it might look like an ordered pair, like in this case, -1, 0. Okay. If it's consistent and dependent, those two lines are on top of each other. If it's inconsistent, then those two lines will be parallel and there are no solutions. Okay, so far?
Yep.
Which method do you prefer so far?
This one.
The first one. The
Drawing a
First one.
line or making a table?
table.
Table. Table would be more accurate.
What's this one? This is just condemnation.
This is the
This is just vocabulary. The third way to solve a system is called the substitution method. Heard of that before, have you, Alex?
Yeah.
The substitution method. Now, the easiest way to figure out when to use the substitution method, okay, that's enough. I don't need to know the definition of that stuff. Get out of here. Yeah, whatever. Is when you have, I just want you to get out of here. Excuse me for a moment. I don't know why it's not working. Well, just get out of here. I don't even like you. Okay. The other way, this is a story problem that I'm not going to look at right now because I don't want to confuse you even more. Is when you have these three all lend themselves really well to the substitution method because you have a variable that's just hanging around all by itself right there. And right there you have one. And right here you have one. Okay? So when you see those kind of lend themselves really well to the substitution method, which means you're going to do this. Get myself some room. Waiting. Waiting. Great. Waiting. Let me try that again. Finally. Okay. So substitution method is just like me. I'm going to have a substitute on Friday. I'm going to leave and somebody's going to come into my place. All right? So what we're going to do is we're going to take this variable that's all by itself and get it all by itself. So we're going to take away 2x from this side and take away 2x from this side, and we end up with y equals 7 minus 2x. Okay? This is me. This is my substitute. I'm going to leave, and my substitute is going to come in. This is me. I'm going to leave, and my substitute is going to come in place of that. So this equation now is 5x minus 3. The y is leaving. 7 minus 2x is coming in its place. Equals 23. Solve it. Get 11x minus 21 equals 23. You get 11x equals 44.
Oh.
And so you get x equals 4. Yay! Now I know the x coordinate is 44.
I like this one. No, that's
Oh, it's 4. Excuse me. The x coordinate is 4. Thank you. Wake me up. The x coordinate is 4. So how do I figure out the y coordinate?
Switch it around and make it so you can substitute the x.
Actually, I'm just going to use that equation that I had before because if I just plug it all in there, I'll know what y is, right? So this is 4. This would be 8. So 7 take away 8 is
One.
-1. I found my solution.
I like this one.
Is it consistent or inconsistent?
It's
Consistent.
Consistent and
independent.
independent. I found the answer. What does that mean? That means if I put a 4 there and a -1 there, I get 23. If I put a 4 there and a -1 there, I will get 7.
What would happen if you would have what are those ones that like overlap
Yeah.
and you tried to substitute it?
Wouldn't
That's
you
coming
probably
up.
get something
Okay.
like over 0 or something?
That's coming up. Okay? That's a good question. Where's my variable that is alone?
The X on top.
All right. So what I'm going to do is add 7y to this side and add 7y to this side. Now be careful because this time
Substitute for X.
I'm substituting for x. This is the teacher. This is the substitute. So make sure you put this in for x this time. So this is 5 times 11 plus 7y plus 4y. A lot of people forget that part. Equals -23. 55 plus 35y plus 4y equals -23. 55 plus 39y equals negative 23. 39y equals minus 55. I get a negative 78. I do the math.
2.
-2.
Y equals negative 2. Right? Don't forget, you're not done. Look at this though. This time, what equals negative 2?
Y.
Y equals negative 2.
I remember we said.
So I gotta go back up here and put that in right here for the y. Which is negative 2 times 7 is negative 14.
So
And
negative 3.
would be negative 3. How do you like the substitution?
I think
I like it a lot.
The substitution method is great.
Substitution method.
The substitution method will always work and you'll always get the exact answer that you need.
So how do we know if it's independent or dependent? Yeah.
What is that?
Well, that is independent and
How do you,
the
It's consistent or
yeah
inconsistent?
consistent.
It's consistent.
but how do you know if it's dependent or
Well, just think about it, because you have a point where it means
Right now, yeah, you've never had you won't, if you see a point, it's consistent and independent. Don't worry about it. That's the only answer you've seen so far.
Okay.
I'll show you when we have one that's dependent. That's when you have parallel lines. Or when you have line on top of the other one. Okay? So you couldn't have one solution. You'd have a whole bunch of solutions. Well, that's one solution right there. Okay with that, everybody?
Yep.
I'm not going to do the third one. We'll go over these again tomorrow. I do want to show you the fourth method. See which one you like better.
Which one did you think we'd like?
Don't tell
I
us
think
yet.
you'll like the fourth one the best. But sometimes substitution works beautifully. Okay?